So far we've just been working with a script and creating and deleting records as we've been working through that script. In this video we're going to create a repeatable data set using a Django management command that we can use in future videos, and this is going to allow us to delve deeper into some of the concepts in Django's ORM. And as well as creating that command, what we're going to do in this video is dive further into the filter and exclude statements in Django. These can be used to control and filter the results that you're getting back from the database based on conditions. We're also going to look at the order by statement to control the ordering of a query set of models. And we're going to look at the exists function as well, which is a Boolean function that returns whether or not any models meet the conditions that you specify. And finally, we're going to look at the earliest and latest functions that can be used with datetime fields in your Django models. And we're also going to dive further into lookups in this video. For example, the greater than and less than lookups, the range lookup that can be used to see if a value is between two boundaries. And we're going to see the in lookup as well, which can be used to check if a particular field has a value that's in a predefined set of values. And we'll look at some other things in this video. It's going to be quite a comprehensive video on some of these topics, so let's get started. Now I've created a GitHub repository for the ORM series. I'm going to commit some of the code that we're going to work on to this repository in the future, but I've put up the starter code that now contains in the core project a management/commands folder, and within this folder we have a Python script called createData.py. Now all the other codes in this repository is just the same code that we've been looking at throughout this tutorial series, but I have added this createData.py script. So if we go to VS Code, what I'm going to do is go to that create data script. This is a Django management command, so it extends the base command class, and that has a handle function. So let's very quickly go over what's going on in this function. And remember, you can clone this directly from the repository and follow along with the video. So we're looking here for a user with a username of admin in the database. We're going to check whether or not that user exists, and if they don't exist, we are creating that super user with the username of admin and a password that we're just setting to test here. So we're getting the user within this if and else statement here. And by the way, if you're not interested in looking at the management command, then you can skip to the next section of the video. Below that we have a list of restaurants, and each element in that list is a Python dictionary that contains values for the fields that are defined on a restaurant model. If we scroll down, you can see that what we are doing in this script is deleting all the existing restaurants from the database, and then we're looping over that list of dictionaries, and we're using the restaurant.objects.create function and unpacking the dictionary of key value pairs into that create function. So that will enter a value into the database for each element in this list of dictionaries, and then below that what we're doing is we're creating some ratings. So I've got a hard-coded value of 30 here, and feel free to change any of these if you want. So we're creating 30 ratings, and we are using the random.choice function in Python to choose a particular restaurant from the query set of restaurants. So this is a rating that will be applied randomly to one of the restaurants. And finally, below that, we are also creating 100 sales in the database. And again, we're using random.choice here to select the restaurant. And for the income generated from that sale, we are generating uniformly a number between 5 and 100. And I should say as well above that the rating that we have here, we are applying a random integer between 1 and 5 for that rating. So this is the management script, and we can run this with the Python manage.py, and we can give it the name of the script, which is create data. That's going to then run this and add these objects to the database for restaurants, for ratings, and for sales. Now what we're going to do is verify that this has worked by going to our scripts directory and the orm script.py file. This is a script that we're running with the Django extensions run script command. What we're going to do is we're going to print to the terminal here the result of executing restaurant.objects.count. And as well as the number of restaurants, I'm going to paste in these two commands here. We're going to also get the number of ratings and the number of sales in the database table. So let's execute this with Python manage.py, and we use the run script command, and the name of this is ORM script. And below here you can see the raw numbers coming from these commands. We have 14 restaurants, 30 ratings, and 100 sales in the database. So these match the values that we had hard-coded here in, for example, this for loop for the ratings, 30 and 100. So these have been successfully entered into the database when we run that management command. So now we have data in the database, let's learn a bit more about querying that database using Django. Now we've already seen methods such as the .count method that gets the number of rows in the database table. And we've seen other methods such as .all to get all of the rows, and the first and last methods to get the first record and the last record in the table. We're now going to expand on our knowledge of the filter and exclude functions in Django. And while we're working with these functions, we're going to also dive further into lookups in Django that allow you to customize the where clause of an SQL query. So let's clear these print statements from the terminal. And I'm going to remove this comment and replace it with another one. What we're going to do is filter down to only the Chinese restaurants in the data. So let's write that statement here below. It's going to be restaurant.objects.filter. And we're going to filter on the restaurant type field, and we're going to set that equal to the restaurant.typechoices.Chinese value. Remember, type choices is a text choices class in Django that defines some values that we can use in the restaurant type field. So if we scroll up here to the restaurant model, we have a type choices class, and we can see some of these values. This is very similar to an enum. It contains some predefined values such as Chinese here in this case, and we are going to search for that when we use the filter command, and we'll be passed the restaurant type in here as a Chinese restaurant. So let's print this to the terminal, and then we can execute the script. And we're running that script below here, and you can see the query set coming back with 3 restaurants in that database table that are Chinese restaurants. And if we look at the query that's being executed here, you can see that there is a where clause here, and we're filtering down to where the restaurant type is equal to Chinese. In this case, that's defined by this ch value that we're storing in the database. So what the filter statement does that we're running here is it takes the keyword argument that represents one of the columns in the database table, and the value we pass in after that is what is searched for in the database, and that's searched by doing an equality here. So we're checking an exact value that's passed in, whether that particular column has records that match that exact value, and then returning them to the caller. Now let's see another way to do this. For example, we might want to check for a restaurant with a given name. So the field that we're going to use here is now name, not restaurant type. And the value, we can remove the enum value. And let's say we're searching for a restaurant called Pizzeria 1. Let's now execute this query again, and we can see the result. And you can see the where clause again at the bottom. We're checking if the name is equal to what we've passed in as the value of this keyword argument. So Django is taking these keyword arguments that we're passing to the filter statement, and it's converting them into where clause statements that are used in the SQL to get the right results back to the caller. So what I'm going to do is store this in a value called restaurant. This is just a variable, and what we're going to do is we're going to print out the restaurant.count function. And of course we expect this to equal 1 because there's only one restaurant in the table that has that exact name called Pizzeria 1. And the .count function is defined on a query set in Django, and a query set represents a list of models that you have coming back from the database. Now, if you only have one model, you might want to just get the value of that directly as a Django model class rather than having it as a query set. So if we remove the call to .count, we are just going to print out a query set in Django, but what we can do is also call a function called .get, and that is going to attempt to retrieve the value from the query set as a Django model, and that will only work if you have one model in your query set only. So let's comment out the connection.queries. We're not interested in the SQL here, and we're going to rerun the script, and you can see the 2 outputs. On the top we have a query set containing a single restaurant with the name that we've passed in, and when we call the .get function, we are converting that query set to a single Django model. Now we can actually do this on one line of code. If we change the .filter function to .get, then when we print the restaurant to the terminal, we're going to see that that's a Django model instance. It's not a query set, but you have to be careful when you're using .get. This is a function that should return only a single row from the database that is then converted into a Django model on the application layer. So if you pass in parameters to the .get function that will return more than one row from the database, that's actually going to cause an error in your application that you're then going to need to handle. So let's go to database browser for SQLite here, and you can see for the restaurant type we have multiple restaurants for all of these, and we have, I think it's 5 or 6 Italian restaurants here. So if we then pass a parameter to .get here that's going to return the Italian restaurants, we would need to remove this and change the field that we're looking at to restaurant type, and we can set that equal to Italian. But we're passing this to the .get function, which should return only a single row, and this particular query is going to return more than one row. So when we try to execute the script, you can see the error at the bottom. We have an error saying that multiple objects are being returned, and that error is telling us that the .get function returned more than one restaurant. It returned 5 restaurants from the database. Therefore, you need to be careful when you are using .get. This should return exactly one model to your application. So if it returns more than one, or if it returns no models, then this is going to fail. So let's go back to the .filter function here, and we're going to get back these Italian restaurants. And when we print this to the terminal, we can see the query set coming back, and this query set contains all of the rows that have Italian restaurants converted into Django models. Now you can check in a query set whether or not any rows have been returned by chaining the .exists function onto that query set. That will return true or false. It will return true if any rows are matched by the query. Otherwise, if we have no rows that match, it's going to return false. So if we execute the script, you can see we are getting back true here because there are Italian restaurants in the database. But if we change the filter here and put in some random nonsense for the name, when we run the script again, we're going to get back false because we don't have a restaurant with a name equal to that value. So that's the exists function. It's very simple to use in Django. What we're going to see now is how to perform queries that have multiple filters in the where clause. So let's remove this code here, and again we're going to filter this down to only the Chinese restaurants. So I'm going to pull out the value from that enum, and let's now rewrite the filter statement, restaurant.objects.filter, and we're filtering down to restaurants with the restaurant type equal to Chinese. Now let's store the value of this query in a variable called restaurants, and we can print it out to the terminal. And then what we're going to do is we're going to uncomment the line below here, and that's going to allow us to print out the SQL queries that are executed in this script. So let's run the script, and we're going to see the output. Now you can see in the query set that we're getting back that we have 3 restaurants. The first one's called Golden Dragon, the second is Chinese 2, and we also have Chinese 3. So this is the same as we had before. We're getting back a query set with 3 restaurants, and if you look at the where clause, we have a single filter operation where we're checking the restaurant type being equal to Chinese. So what if we want to add another filter statement here? That can allow us to execute more advanced logic by using the AND, OR, or NOT clauses in SQL. So let's make the terminal smaller here. And all we need to do if we want to chain an AND statement to the where clause is just pass another keyword argument to filter. So as well as the restaurant type being Chinese, you can see below that we have 2 restaurants that have a name that begins with the letter C. So if we just want to get back the restaurants that are Chinese and have a name that starts with C, we can use the name field on the model, and we can use the startswith lookup. And as I said in the previous video, lookups allow you to customize what's passed to a where clause in SQL. In this case, we're going to check names that begin with the letter C, and this is going to create an AND clause in the SQL where clause. It's going to check for restaurant types that are equal to Chinese and whose names begin with the letter C. So let's now clear the terminal, and I'm going to run the script, and we're going to see the output here. And you can see the query set that we're getting back no longer has 3 records, it's down to 2, and those 2 records are the ones that both begin with the letter C. And if we look at the SQL statement, you can see the clause that we had before where the restaurant type is equal to Chinese. But we also have another clause here where we are looking at the name field, and we're finding records whose name is like this particular pattern here, where we have the letter C and then the wildcard percentage operator after that. And that pattern allows us to check for restaurants that begin with the letter C. But the important thing to note in this where clause is the AND operator here. So the resulting query set is going to have restaurants that begin with C and whose restaurant type is equal to Chinese. So in order to chain these AND clauses together, all we need to do is pass different keyword arguments to the .filter or exclude functions. So this is the startswith filter. We're going to look at another filter now, the in filter. So I'm going to clear this code and define 3 variables here. Let me tab these over. We have Chinese, Indian, and Mexican, and we're taking the values from that enum and we're storing it in a variable. Let's now create a variable called check types, and we're going to set that equal to these 3 values. We're just going to pack them into a list. That's the Chinese, the Indian, and the Mexican values. Now what we're going to try and achieve here is we're going to try and find all restaurants that are one of these values. So let's create a variable called restaurants, and we're going to use the restaurant.objects.filter statement again. And again, we're going to check the restaurant type, which is a field on the restaurant model. But instead of just using an equality here, we're going to chain the in lookup. So 2 underscores and then in, and we can set that equal to a sequence in Python, for example, a list that we have above. So what this is going to do is it's going to find all restaurants whose type is one of these 3 values. So let's print these restaurants to the terminal, and we're going to run the script again. And you can see at the top here that we're getting back the query set that contains Chinese restaurants, it contains Indian restaurants, and it also contains the Mexican restaurants as well. But it doesn't contain the Italian and other restaurants that we have in the data. And if you look at the SQL query, you can see a new operator that's being used here, and that's the in operator. And that's used to check if a particular column's values are in this set that we define after the in operator. So we're checking if the restaurant type is one of Chinese, Indian or Mexican. That's the query, and it's returning that query set to Django consisting of the correct models. So we've seen a bit more about how to use filter, how we can use multiple keyword arguments to chain them together using an AND clause. And we've also seen how to use the in lookup here in order to translate that to an in SQL operator to check if a particular column's values are in a predefined set. We're now going to look at the exclude method in Django, and this method is the inverse of the filter method, and it results in exactly the same SQL query that's executed by the filter method, but it simply adds a not operator before the where clause. So let's see that in action. We're going to remove all this code, but I'm going to keep the reference to the Chinese restaurants around, and let's say that we want to get all the restaurants in the data except for the Chinese restaurants. So we don't want to get Chinese restaurants, we just want to get any other type of restaurant. So what we're going to do is write a query here and store it in a variable called restaurants. So it's going to be restaurant.objects.exclude, and instead of filter we're now using this exclude method, and we pass the condition to that. So restaurant type equal to Chinese is the condition, and unlike filter, when it's going to return values where the restaurant type is equal to Chinese, this is going to add a not to the where clause, and it's going to then result in returning any restaurant whose type is not Chinese. So let's print these restaurants to the terminal and we can execute the script, and I'm going to make the terminal bigger here so we can see the query. You can see at the top the query set we're getting back contains the Italian and Indian restaurants and so on, but it doesn't contain any Chinese restaurants. And if we look at the SQL statement here, we're getting all the values from the restaurant table, but we have this where not statement, and we're getting values back where the restaurant type is not equal to Chinese. So what happens with the exclude function in Django is that it adds a not clause to the SQL statement, and specifically it adds it to that where clause when it's doing the filtering. So when you use the filter function, you're saying give me back the records that meet the conditions that we're passing to the function as arguments. But when you use the exclude function, we're saying give me back all the records that do not meet the conditions that we're passing. And we can use lookups with the exclude function just as we did with the filter function. So let's grab Indian values from that enum, and we're now going to get all restaurants where the value of the restaurant type is not Chinese or Indian. So in order to do that, we can remove this equal sign and we can use the in operator, and we can pass a list here equal to Chinese and Indian values in that list. So this is going to exclude any restaurants where the restaurant type is one of these two values. So let's execute the script and we can analyze the output at the top here. And again, we have in the where clause here a not operator, and we're checking if the restaurant type is in Chinese or Indian, and we're excluding that with the not operator. So if you understand the filter function, you should understand exclude as well. It's just the inverse of filter. So let's now move on. We're going to show some additional lookups in Django now. So let's say we wanted to get all restaurants that started with letters A, B, C or D. We can use the less than lookup for this. So let's write the query now. It's going to be restaurant.objects.filter. And if we want restaurants whose name begins with A, B, C or D, we're going to use the name field, and we can use the less than lookup. Now the value that we pass here is the letter E, and what that is going to do is it's going to give us back all restaurants in the data whose name begins with letters A to D. So let's store that in a variable and then we can print it to the terminal. Let's now run the script and we can analyze the output of that query. So you can see at the top we have 3 restaurants printed to the terminal, and these begin with the letters B and C. So we're getting back all restaurants whose letter for the first name starts with something that is less than the letter E. And if we look at the where clause in the SQL, you can see that we're looking at the name column and we're getting back any restaurant whose name is less than the letter E. So when you use the less than lookup in Django, it's going to translate that to this less than operator in SQL, and it's going to use that within the where clause to filter the results you're getting back from the table. Now it's probably more common to use the less than lookup with numerical data rather than with a char field or textual data. So what we're going to do now is we're going to look up a different field, and I'm going to look up the longitude field. And let's get all longitudes that are greater than the number 0 here. So this is another lookup very similar to the LT less than lookup. This one is greater than. Now basically when you have a longitude that's greater than 0, you have a longitude that is east of the city of London in the UK. And that's because London is basically on what's called the prime meridian. Now longitude is a float field in the database, so if we're using the greater than lookup here, it's going to check for values, numerical values that are greater than what we pass in, which in this case is 0. So let's execute the script, and this time we can see two values in the query set, and it's for a pizzeria and an Italian. And I've hard coded some longitudes into the data set, so these are presumably in Italy, which is to the east of the UK. And again, let's look at the SQL where clause. We're looking at the longitude here, and we're checking for longitudes that are greater than 0.0. And we're using the greater than lookup, which converts to this greater than operator in the SQL where clause. So this query is giving us restaurants that are east of London, basically. What if we wanted to get restaurants that are west of London? Well, all we have to do is either change the filter to an exclude function. You can see this time we're getting back all restaurants that are west of London, and in the SQL statement, here is the lookup where we're checking if the longitude is greater than 0, but this time we have a where not clause used instead. And another way to check if restaurants are west of London is you can continue using the .filter function, but change the lookup. So we can look up values that are less than 0 in this case, and that should give us the same output, but it's going to use a slightly different query. We don't have a where not clause, we just have a where clause, but we've switched the operator from greater than to less than. So it's different ways of achieving very similar or the same results in Django using these operators. So let's see a few more examples here of these lookups. I'm going to use the sale object now, and I'm going to store these in a variable called sales. And the sale object has a field called income, and we're going to get incomes that are greater than 90 in the data. So let's execute this. And if we look at the result here, we get a bunch of sale objects in this query set, and the where clause for this is looking at the income field and getting values greater than 90. So I think it's easy to understand the greater than and less than lookups. And by the way, there is also greater than and equal to. You just put an E at the end of that, and also less than or equal to as well. So these exist if you want to check if something is greater than or equal to, or less than or equal to a value. What we're going to see is another lookup here, and then we're going to move on to ordering, and this is the range lookup. So to the range lookup, you can pass a tuple of two values, the lower boundary for the lookup and the upper boundary for the lookup. So let's say we wanted to get all sales that have an income that's between 50 and 60. Let's execute this script with the range lookup, and we get back some objects, but let's look at the SQL here at the where clause. We're looking at the income field, and we see a new SQL operator called between here, and we're getting incomes that are between 50 and 60. What's happening is it's translating the values that we pass in to an SQL between statement, and it's getting back the records that are between those two values. And just to prove that, we're going to use a list comprehension here, and for each sale in the sales that we're getting back, we're going to print out the sales income, and we're going to make sure these are all between the values 50 and 60. So you can see these decimals coming back, 51, 58 and so on. All of them are within, or rather between, those boundaries, and that's what you can do with the range lookup. It's quite powerful, and you can also use this with date times in order to get all the rows from a database that fall between two dates. And that can be very useful for performing date-based analysis, and we're going to see more of that later in the series. Let's now move on to ordering records in Django QuerySets. So when you query a database, you often want to get back records in some sort of order. And SQL has a statement called order by, which can be used to achieve this. Now the default ordering in a Django model is by the primary key of the particular model. And that's usually an ID field that's numerical. So when you call restaurant.objects.all, you get back a query set that contains all of the rows in the database, but they're ordered by the primary key of the table, the ID, but you can override this if you want, and we're going to see how to do that now. So I'm going to remove these two lines of code, and we're going to fetch the restaurants by using the restaurant.objects.orderBy function. And the orderBy function allows you to specify an ordering to get back a query set of records in a particular order, and you can order by a particular field's values. In our case, we're going to get back the restaurants ordered by the name value. So let's print these restaurants to the terminal, and we can execute the script. And you can see the output at the top here. We have the restaurants in a query set, and these are ordered by the name. So you can see the name beginning with B, then C, then G, and so on. And if we look at the SQL statement, you can see the order by statement appearing in that SQL, and we're ordering by this particular field called name, and we're doing that in ascending order by default. An ascending order for textual data means we're starting at the letter A and we're getting back all records in order up to the letter Z. So this allows us to customize the ordering of a query set, and we can use Django's order by function to do that. But what if we wanted to order it the other way around? For example, if we wanted the restaurants to begin with a later letter first, what we could do is, because we have these in order of the name, we could use the .reverse function, which is another function on Django QuerySets. If we chain that to the order by and then re-execute the script, you can see we get back the restaurants in the reverse order. And looking at the SQL, you can see the order by statement. This time we're looking at the name field, but we have a descending argument after that. So it's going to get the records from top to bottom, essentially. So that's one way of doing it. We call order by, we pass the field, and then we can reverse the query set. What we can also do is we can pass a minus to the field name like this. And this is a Django specific syntax where we are telling Django, just by using this minus operator, that we want the values back in reverse order. So let's save that and execute the script again. And this gives us back the same results as we got when we called order by and then the reverse function. And you can see that descending keyword in this order by clause. And this is going to return all the restaurants where the name field is ordered from top to bottom in the query set. And this works with any field. It doesn't just work with textual data. You can use this with numerical data, and you can use it with datetime fields as well. For example, if you wanted to get back all sales, we have in the sale table a datetime field that captures when the sale occurred. So if you wanted to get back the most recent sales, we can go to our ORM script here and we can use the sale.objects.orderby, and this time we're going to pass the minus datetime to that. This is going to return the most recent datetimes to us, earliest in the query set. So let's execute this and we can go to the terminal here, and you can see we are getting back a bunch of sale objects. But if we look at the order by statement, it's ordering by the date time, and again, it's in descending order. Now I'm going to bring back the code for getting the restaurants ordered by the name. Now there's one problem with this statement for textual data, and that's that it doesn't take into account the case of the restaurant names that are in the database. So what happens if some restaurants begin with lowercase characters in the database and others with uppercase characters? Let's demonstrate this problem by pulling a restaurant out of the database. So we can do that with restaurant.objects.first. And what I'm going to do is reset the name of the restaurant. So we're going to use the existing name, but we're going to convert it to lowercase. Once we've done that, we can save the new value to the database. And then we're going to see an example of what's going wrong here when we run this script again. So let's run it. So if we look at the query set that's coming back here, you can see we have everything ordered by the name as before, but we have at the end here a restaurant called Pizzeria 1. And this begins with the letter P, but it's a lowercase p. And this comes after other restaurants such as Taco Bell. And that's a problem because we're ordering by the name and we don't particularly care about the case here. We want to make sure that the returned values are case insensitive. So how can we do that in Django when we have a text field and we're ordering by that field, but that particular text field might have different cases as the first letter? Now it turns out that Django allows you to execute database functions when you're running queries. So what we're going to do is we're going to bring an import in at the top here from django.db.models.functions. We're going to import a function called lower, and we can use that in the order by clause to lowercase the values in a particular column when we're doing the ordering, and that will result in a case insensitive ordering at the end of that process. So what I'm going to do is remove these 3 lines of code, and we're going to use the lower function directly in the order by statement here, and we pass the name of the field that we want to apply the lower casing to. So that's the name field, and that is going to be used as the values to the order by function. So let's now execute this script and we can look at the output at the top here. You can see this time we have the Pizzeria 1 appearing in the correct place within the resulting query set. So in order to get a case insensitive ordering, we are using the lower function on the name field and passing that to order by. And if we look at the SQL that's executed here, we can see that we're actually executing a database function called lower to lowercase the restaurant name as we're doing the ordering. So Django's function modules allows you to execute functions at the database layer, and this can be useful to do your processing on the database server rather than pulling values into Python and then having to amend all of those values in your code base. So let's demonstrate a few other things with ordering here. We're going to show that we can actually use this with datetime fields. Now we've already shown this, but what I'm going to do is go to models.py. If we look at the restaurant model up here, we have a date open field. So I'm going to quickly show an ordering by that. So we can remove the call to lower here, and we're going to paste in the field date opened. So let's save that and execute the script. And when we order by the date open field, what it's going to return first of all here is the restaurant that was opened at the earliest date up until the restaurant that was opened at the latest date. Now we've already seen that with the sale model, but I want to show something else here, and that's how to index into a query set. Now we can index in at element 0 here, and if we execute the script and look at what we get back a model. So when we index in at one particular index, Django will see that indexing in a particular element, and it will convert that to a limit clause in SQL. Now limit is an SQL keyword, and it's used to control the number of rows that are being returned to the caller. And when we limit to 1 here, it's going to return a single row, and that's because we have indexed in, and our indexing doesn't contain any slices. We're hard coding an actual index, an actual number here, so it's going to return a single model to us, not a query set. Now if we use a slice, for example, we could get the first 5 records in the restaurant table in order of the ones that were opened earliest. If we execute this and look at the results, this time we're getting back a query set containing 5 restaurants, and you can see in the query that's being executed here, we're ordering by the date opened field, and we're limiting to only 5 results in the output. And that's again because this time we're using a slice operator, and we're slicing into the query set, and we're getting the first 5 records in the database table. Now what if we wanted to get all records between 2 and 5 here? We can use this notation, and this is just coming from Python list indexing notation. This will give us back all records between 2 and 5. So let's now see the resulting SQL query for this one. If we expand that, you can see we get back 3 restaurants, and this time we can see a new keyword in the SQL statement, and that's the offset. So the query that's being executed gets back all restaurants from the database in order of date opened. But at the end of the statement, we're limiting to only 3 rows being returned, but we're also offsetting by 2. And that's because if we go back to the code here, we are indexing in with this particular slice in Python. We're starting at element 2 and up to element 5. So that's going to return a query set of 3 models, and we're offsetting the results by 2 because of that indexing. Now I'm going to finish this section on ordering by looking at a default way of ordering your models. So what I'm going to do is go to models.py, and in fact I'm going to copy this import of the lower function out of the script and into the top of the models.py file. And you can set a default ordering on a Django model. For example, we're going to do that on the restaurant model here. And you can do that by defining a meta class in your Django model. So let's define an inner class here called meta. And this is a common practice in Django. The meta class can provide options that are applied to your Django models. Now the meta class has a field called ordering that you can set to a tuple or a list that will specify the default ordering for that particular model when it's retrieved with a query set. So what we're going to set this to is the lower name field. And by setting the ordering to this, it means that when we call any operations on this model with the ORM, unless we specify a different ordering, it's going to try and order it by this default ordering, in our case by lowercasing the name field. So let's go back to the ORM script.py, and we can remove the .orderBy call, and what we're going to use here is restaurant.objects.all. It's going to return all the restaurants to us when we execute this script below. Now we're not specifying any ordering here, but you can see that there is an order by clause in the SQL that's being executed, and again we're passing the lower function of this name field. So if you have a default ordering that you want to use unless you specify otherwise, then you can go to your model and define a meta class if you don't already have it, and pass an ordering field into that meta class. And you can pass a particular column in there, and you can also use functions as you see here in order to control that ordering. And if 2 rows have the same name, then you can also pass additional values to that. For example, you might want to order by date opened if 2 restaurants have the same name. We're just going to keep it to the name field, and we're going to save this file, and we're going to move on to the earliest and latest functions in Django. Now earliest and latest are kind of similar to the first and last functions, and they're convenient when you're working with datetime fields in Django. Let's go back to the ORM script.py, and what we're going to fetch here is a single restaurant, and we're going to get the restaurant that was opened at the earliest date. So what we can use is restaurant.objects.earliest, and we pass a field or a set of fields to that. Now the field we're going to use is the date opened field. That's a datetime field. So the concept of having an earliest record makes sense with a date. So the .earliest function is just a convenience function. It allows us to take a particular database table and get back a record, and that record represents the earliest date opened from this particular set of restaurants. If we execute the script and look at the output, you can see that we get back a single model. So .earliest doesn't return a query set, it returns a single model to the application. And you can see the query has it ordered by the date opened, and it's limiting to a single row of output. So earliest for a datetime is kind of similar to the .first method, and there's an adjacent method called latest as well. And if we execute that, we can see the resulting query. It's going to return another given restaurant. Again, it's a model, not a query set. And again, the order by statement is ordered by the date opened that we're passing as a field to the .latest function. And this time it's in descending order, and again limited to just a single row. So earliest and latest are just convenience functions in Django when you have a datetime field on a model and you want to get the earliest and latest rows from that particular table based on that datetime field. And you can see we're passing the field to the model here, but what we can actually do is we can go back to models.py and we can pass another field to the meta class, and that's getLatestBy. And this can be set to any datetime or date field in your model. So we have the date opened date field here. We're going to get the latest by this particular field, and what that means is when we go back to the ORM script.py, we can just call the .latest function, and it's going to by default apply it to that field in our model. So let's re-execute this, and we should see the same output of Pizzeria 3 here. So if you have a datetime field in your model that you're typically ordering by, you can either use it as the ordering field itself, or you can use the getLatestBy and set it to that value, and that can help you when you're wanting to get back the latest, the most recent record from the database, or the most distant, the earliest record from the same table. So this has been quite a long video. Let's finish by looking at how to filter by foreign key in Django. So let's say we want to find all ratings associated with restaurants beginning with the letter C. So let's remove this code here, and we're going to set up a query here, rating.objects.filter. So this time we're using the rating model in our application. Rating has a foreign key to restaurant, and that's called restaurant, that field. And we can use the 2 underscores to specify a lookup to that related object. So the restaurant is the related object, and it has a field called name. What we want to do is get all restaurants whose name begins with the letter C. So what we can do is chain a lookup to that foreign key field, and that's the startswith lookup, and we can set that equal to the letter C. Let's store the value of this in a variable called ratings. And let's just quickly go over this syntax one more time. We're filtering the ratings, and we're looking at only ratings whose restaurant's name begins with the letter C. So we can use the startswith lookup on this foreign key field called name. So when we're filtering by a foreign key field, we use the name of the field that refers to the foreign key. We have 2 underscores to refer to any fields on that related object. And finally, we can also optionally do lookups as well to that particular field. So let's print out these ratings to the terminal and execute the script. And you can see a query set of ratings here. And if we look at the SQL statement, you can see we have a where clause where we're looking at the restaurant name being like the letter C here. But something to notice when we do this query is we're actually doing an inner join on the restaurant table, and that join is being done by looking at the restaurant ID from the rating table. That's the foreign key, and it's joining that based on the equality where we're looking at the restaurant table's ID field. So it does the join, and then it does the filter where it only gets back the restaurants whose name begins with the letter C. So when you do a filter like this in Django, where you're doing the filter on a foreign keys field, Django is going to translate that into a join statement in the SQL. And let's see one final example in this video. Assume that we want to get back all sales that belong to a Chinese restaurant. Let's change these variables. We're going to refer to sales, and it's going to be sale.objects.filter. And again, we are filtering by the restaurant, but we can remove the rest of this. This time we're going to look at the restaurant type field, and we're going to look for restaurants that are Chinese restaurants in this query, and we can print those to the terminal. So let's execute the script, and you can see again in the SQL we get back a query set of sales, but we also have this inner join going on in the SQL statement, and the sale table's restaurant ID foreign key column is being joined to the restaurant's ID, and in the where clause we're looking at the restaurant type and we're checking for those restaurants that are Chinese restaurants. So I hope that demonstrates how to do foreign key filters in Django, and that's all for this video. We've covered quite a lot of topics in this video. We've looked more into the filter and exclude functions, including how to use lookups with those functions. We've looked at how to order records in Django using the order by function and also by using the ordering field of a meta class. And we've looked at the earliest and latest functions that are defined on models that have a datetime field. And finally, at the end here, we've seen how to filter query sets based on the value of a foreign key field. In the next video, we're going to look at the n+1 problem in Django, and we're going to look at how we can solve that using some of the utilities offered by the ORM. We're also going to look at a tool called Django Debug Toolbar and how that can help you when you're developing Django applications. So thanks again for watching this video. If you've enjoyed it, please like and subscribe to the channel, and we'll see you in the next video.